Hello everybody out there in YouTube land. This is Good Times for All, or Zachary Zabala, if you prefer. Today we are going to be going into the new book of knowledge again. This will be, I believe, volume 18, letter T. There's going to be a few things I'd like to talk about in this book here. Today we're going to be focusing on time, just to show you. 1980 will be the latest date you will find. So these are getting up there in age. 36 years old, getting ready to turn 37 here pretty soon. Pretty good shape for their age. Really neat books. Here we go. Time. It talks about a world without clocks. Long time ago, how people lived. I'll just scroll through this. You guys, if you want to read it, you can pause it as you're going. It talks about how people used, the sun, moon, and stars to measure everything. It talks about the amount of daylight grows longer. It's going to be summer. When it gets shorter, winter's coming, yada yada yada. The clock calendar of the earth served early men, and it serves us today. Most modern clocks and calendars are timed to it. I found that very interesting. Most modern clocks and calendars are timed to it. So not all. Now you got to think about this. I don't know if the Chinese calendar is or not. I haven't done any real research on any of this. Or the Indian calendar. I'm not sure how they go. But I know that's a very large majority. Not a majority, not a very large majority, but there's a lot of people in those countries. And if they don't go by these clocks, which I don't know if they do, remember, but if they don't, that means that not even half the world goes by this then. So just remember that when they say most modern clocks and calendars, but there could be just a couple calendars and clock systems that don't go by it, but that many more people use them. Okay, so we got that out of the way. There are 10 to 2 movements of the earth that mark the sun and stars, that make the sun and stars appear to move. One movement is the steady spinning of the earth on its axis. Remember that, the steady spinning of the earth on its axis. And it goes through the axis as an imaginary line running through the earth from pole to pole. The spinning gives us day and night. Okay. The other movement is the earth's journey around the sun. The journey gives us the seasons and a year, blah, 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 blah. Their measurements give us the 2 main units of time. The solar day, sun day, and the solar year. All our other units of time are based on these 2. Then it goes into the solar day. The earth spins on its axis, yada yada yada. 360 degrees. One complete turn of the earth. Measuring time is tick in the ground. 3,000 years ago, they had sundials. I'm just trying to go show you all this stuff, so if you want to read it, you can. There's just certain things I really wanted to point out. It talks about the Babylonians and the Egyptians using this a lot, being the first civilizations to use it. And then 600 years ago, mechanical clocks were invented. They started off into 12 parts and then finally were made into 24 parts called hours, after the Greek word for time of day. Some countries have 24 hours. Some people have 2 sets of 12. The military time always goes by 24, so there's no mistakes. 6 a.m., 6 p.m. They just go 6 or 18. Some clocks, some scientists, they measure tiny fractions of a second all the way down to even billionths of a second. It's pretty amazing. If you have a sundial, you can observe something interesting about the solar day. Its length varies. That is, the sun does not reach its zenith every 24 hours on the dot. Sometimes the period of time is a little longer than 24 hours, sometimes it is shorter. The length of a solar day may vary by anything from a few seconds to about a quarter of an hour. Wiki says about 16 minutes, maximum. The variation is caused by several things. One is changes in the Earth's speed as it travels around the sun. I found that interesting. Not just that, hold on a second here. Not just the Earth's speed changes, but that they only mentioned one. Now this variation is caused by several things. Several. One is changes in the Earth's speed as it travels around the sun. Now you can't tell me that that's going to throw that off by 15 or 16 minutes. What happens? I could see, I don't know, we would feel that. We would have to feel that, wouldn't we? I don't know. In their model, the Earth is still big, and I can't really say what it would be like to be on something that big moving at those speeds, because it's so hard to imagine and perceive. I'm not going to even try. It's things like that are beyond what we know, what anybody knows. I mean, you can do the math and this and that, but to say you can feel that difference, or can you measure this difference besides just the speed? Can you measure the Earth changing its rotation speed? Has anybody ever measured that? I'm not sure. I do not know. Okay, but this is how we got our average day. Therefore, astronomers measured the length of every solar day in the year and averaged the results. So, they then said that the mean, or average solar day, is 24 hours long. Our watches and clocks record the passing of mean solar days. That is one reason why your watch is unlikely to show true noon. True noon is always when the sun is at its zenith, or its highest point in the sky. The sun will make an arc, the arc right here. And then right there at the top, before it starts heading back down, that's the sun's zenith. And that is noon. Noon here, right now, where I live in northern Indiana, is 12:44. Because of daylight saving times, we're an hour back still. So it's really 11:44, but it's 12:44. The difference in solar time amounts to 4 minutes for each degree of longitude. So every degree of longitude that you go over, which I think is 69 miles, something like that, is equal to 4 minutes on the clock. The sun goes by. So the sun moves. That thing's moving 60 miles every 4 minutes over the Earth. whether it's spinning or whatnot. Okay. Therefore, the difference is 60 minutes or 1 hour for each 15 degrees of longitude. The time meridians. Each time meridian lies at the center of the standard time zone. The time zone is 15 degrees wide, 7.5 degrees on each side of the meridian. Okay, now we're going to get into AM, PM. You see right here, it talks about early divisions of the solar day. Yada, yada, yada. I know right here. AM and PM. If you want to read the beginning part of it, there you go. But this is the part I was kind of interested in. Come on, focus in for me. Oh, what's going on here? Okay. The time, okay, that is the sun passed, we'll just say the meridian, an hour ago. The time may therefore be written as 1 p.m. PM stands for post-meridium. Not meridian, meridium. A Latin phrase meaning afternoon. So that's all PM is. It stands for a Latin phrase meaning afternoon. The time may therefore be written as 11 a.m. AM stands for ante-meridium, which means before noon. Midnight may be written as 12 p.m. to set it off from noon, which is always weird to me because my clock says 12 a.m. in the morning. It always says 12 a.m. at midnight, not 12 p.m. But this is 30, going on 37 years old. So we may do things a little different now. Excuse me. Where does time begin? Look now at a map of the world. And they give you this over here. We're just going to look at the map sideways. It doesn't matter which way you look at a map. The lines are always the same. And right here it says prime meridian, 0 degrees. Oh, here's the degrees and the hours. Back it up a little bit. It won't be in focus all that well. But there you go. The prime meridian runs through England right there. Or Greenwich, England. Right here is where it's all based off of. Okay. So that's the map they give you. Wouldn't it have been better, a nice circle map, like the UN map? Or the map that's used by all those international organizations and corporations? All their navigating maps are the azimuthal equidistant map. I'm still trying to find a school book or not a college book, but you know, elementary school or a kid's encyclopedia that shows the azimuthal equidistant map. I'm still looking for one. I mean, that'd be a perfect example of how everything works, showing it like a clock. If you wanted to show it for time and how time works, why you would show it like this is beyond me. It would be so much easier to show something moving 360 degrees in a circle. But that's just me, I guess. Okay, so the meridian runs through Greenwich, England. It is numbered 0 and is called the prime meridian. It is a starting point. All of the meridians are marked off east and west of Greenwich. Now you have to remember, not everybody does this. This is not for all calendars and clocks. This is for our clock and how we go about saying what time it is in these other places on the earth. Not by what the people that live in these places on the earth go by. We have to remember that when we read stuff like this. Numbered 15 degrees west, 30 degrees, and so on up to 180. And then you go moving eastward from Greenwich, the exact same, up to 180. So there is no, 270 degrees west. It is 0 through 180 west or 0 through 180 east. It's split into two halves. Let's see. The correct time. Here, I'm sorry. If you would like to read on, I'll go over this real quick here. Talks about time zones and how you have to change times and moving ahead and moving back and changing your days on the calendar using a globe. If it's hard to understand, it would be so much easier explaining it all on the azimuthal equidistant map. Okay, the correct time. Clock time the whole world over is based on mean solar time at Greenwich. Astronomers at Greenwich Observatory check their clocks against the sun on a particular star or a particular star. They check the exact time when the sun or star crosses the meridian. Talks about who else does this. There's one up in Canada, the Dominion Observatory in Ottawa. In the United States, the Naval Observatory in Washington, D.C. That's where I get all my information from. I don't know if they still do this. They sent out signals over the radio waves. 4 naval radio stations and 2 stations run by the National Bureau of Standards to give the exact times. The clocks used for keeping the correct time, I do not know if these are still the times. Remember, this is 36 years ago. It talks about how much more accurate the clocks are than the older types of clocks. The United States Naval Observatory, at least they used to use, I'm not sure if they still do, quartz crystal controlled clocks. They have electric motors that are controlled by the vibrations of the quartz crystals. They vibrate at such a constant rate that the clocks keep time to within 1/500th per second a day. That's pretty good. National Bureau of Standards has an atomic clock. Motion of cesium atoms. The clock is said to be extremely accurate. It seems to have an error of only 1 second in 300 years. Now that is super amazing, folks. Here's my clock. I don't use it too much. It's a mechanical clock though. You have to wind it. As you see, I haven't wound it in a while. I guess I could show you that real quick. I wanted one we couldn't see all the guts inside, but they were quite expensive. This wasn't super cheap by any means, but they can get really expensive. But I wanted a mechanical clock. This one every 27 minutes. I gain a second. So it's not horrible. It's like a minute a day, something like that. It's off. But it could get me close to solar noon, and then I'd just take out my sextant and start measuring it and watch it hit its top, and then watch it go down, and then set my watch to that. Yeah, Charles Hubert of Paris. It's a pretty watch. I like it. Pretty. But anyway, yeah, this is what I was gonna use for keeping time, but it's not as accurate as I would like. These are just amazing. When you talk about 1/500th of a second per day, that's pretty good. And that's pretty much about it. It's going to go into the calendar and stuff like that, but this is already running 20 minutes long. I'm going to quit here. It talks about the moon calendar, the moon-sun calendar, the solar calendar, and how we got into where we are today. And it's pretty interesting itself. Making a sundial, if you're interested in that. Real quick. I'll throw that in there. Whoop. You can pause it as you need to. Alrighty, folks. Well, I hope you learned something. I did. It was really interesting. The part that got me the most was the whole that it changes by 16 minutes. That's just amazing to me. I couldn't believe that. But anyway, this is Good Times for All signing out. And I hope you learned something. I did. Thanks for watching.